Every criminal, no matter how careful, leaves something behind. A single fiber, a grain of soil, a strand of hair invisible to the naked eye. This is the foundation of one of the most powerful yet underappreciated branches of forensic science: trace evidence analysis. Welcome to Forensic Expert Alliance of Bangladesh. Today we're diving deep into how forensic experts use microscopic and often invisible clues to solve crimes, identify suspects, and bring justice to victims. By the end of this video, you'll understand not just what trace evidence is, but how it transforms from a barely visible particle into courtroom admissible proof. To understand trace evidence, we must start with its foundational theory, Locard's exchange principle. Formulated by French forensic scientist Edmond Locard in the early 20th century, this principle states that every contact leaves a trace. When two objects come into contact, material is exchanged between them, however minute that exchange may be. This means a perpetrator will both bring something into a crime scene and take something away from it. A criminal may leave behind fibers from their clothing, and in turn carry away soil, hair, or biological material from the scene. This exchange, no matter how microscopic, forms the backbone of trace evidence analysis and remains one of the most cited principles in forensic science today. Trace evidence comes in many forms, and forensic experts are trained to recognize and collect each type systematically. Fibers are among the most commonly encountered trace evidence, originating from clothing, carpets, or upholstery. Hair evidence can reveal information about a person's identity, and with root material intact, can even yield DNA. Soil and mineral particles can place a suspect or victim at a specific geographical location, since soil composition varies significantly between locations. Glass fragments, paint chips, and gunshot residue provide crucial links in cases involving vehicles, break-ins, or firearms. Even pollen and plant material have been used to trace movement between locations. Each of these evidence types, though small in size, can carry significant weight in reconstructing the sequence of events at a crime scene. The value of trace evidence depends entirely on how carefully it is collected and preserved. Improper handling can destroy evidence or introduce contamination that compromises an entire case. Forensic teams use specialized tools such as tweezers, tape lifts, and vacuum sweepers to collect trace materials without altering their structure. Every item collected must be documented, photographed in place, and packaged separately to prevent cross-contamination between samples. Chain of custody documentation begins the moment evidence is collected and must be maintained without interruption until the evidence is presented in court. This meticulous process ensures that what starts as a nearly invisible particle at a crime scene can later stand up to rigorous scientific and legal scrutiny. Once trace evidence reaches the forensic laboratory, a range of scientific techniques are employed to extract meaningful information from it. Microscopy remains a fundamental tool, allowing analysts to compare fiber structures, hair characteristics, and material composition at a cellular level. Spectroscopy techniques help identify the chemical composition of paint, glass, or unknown substances. Chromatography is used to separate and analyze complex mixtures, particularly useful in identifying accelerants in arson cases or drug residues. When biological material is present, DNA analysis can provide a definitive link between evidence and an individual. These laboratory methods transform raw physical evidence into scientifically validated findings that can withstand cross-examination in court. Scientific findings alone are not enough. Trace evidence must be presented in a way that a judge and jury can understand and trust. Forensic experts serve as expert witnesses, explaining complex scientific processes in accessible terms, while defending their methodology under cross-examination. The strength of trace evidence in court often lies not in a single piece of evidence, but in the cumulative weight of multiple trace elements pointing toward the same conclusion. Defense attorneys frequently challenge the chain of custody or the statistical significance of a match, making rigorous documentation throughout the process absolutely essential. Courts increasingly rely on trace evidence, particularly in cases where direct evidence, such as eyewitness testimony, is unavailable or unreliable. Trace evidence has played a decisive role in countless criminal investigations worldwide, often solving cases that would otherwise remain unresolved. In hit-and-run cases, paint transfer analysis has identified the exact make and model of vehicles involved. In cases of physical altercation, fiber transfer between a victim and suspect's clothing has established contact even when no witnesses were present. Soil analysis has been used to confirm or refute a suspect's alibi by proving whether their claimed location matches the geological composition found on their shoes or vehicle. Even in cold cases decades old, preserved trace evidence has led to breakthrough identifications when re-examined with modern analytical techniques. These examples highlight why trace evidence remains one of the most valuable tools available to forensic investigators today. Trace evidence proves that in forensic science, size does not determine significance. A single fiber, a grain of soil, or a fragment of glass can become the deciding factor in a criminal case, revealing truths that might otherwise remain hidden forever. As forensic science continues to advance in Bangladesh and around the world, the meticulous practice of trace evidence collection and analysis remains as vital today as when Locard first articulated his exchange principle over a century ago. Thank you for watching this episode from Forensic Expert Alliance of Bangladesh. If you found this valuable, please like, share, and subscribe, and let us know in the comments which forensic topic you'd like us to cover next.